All right, can everybody hear me out there okay? Everybody good? Okay, awesome. All right, well, thank you all for coming today to this session. We're going to be talking about network firewall and policy creation with Suricata. We'll go through some of the best practices for Suricata, as well as some of the policy considerations you'll be interested in. Just a little bit about myself. My name is Michael Leidy. I have a background in network security. I've been at AWS for about a year and a half and have a lot of conversations with customers around network firewall. So if that's something you're interested in here, obviously, as you're coming to the session, please connect with us afterwards. We'd love to hear some of your feedback. And I'll let Jesse introduce himself as well.
Hi everyone, I'm Jesse Lepich. I'm a security solutions architect with AWS, specializing in network firewall and other perimeter protection security services.
Thanks, Jesse. Right. So quickly go through the agenda here. We're going to go very brief overview of what AWS Network Firewall is. Presumably a lot of you already know about it since you're here. Jesse's going to cover some of the best practices for network firewall, and then we'll do a walkthrough at the end of some custom Suricata rules and hopefully give you a little bit of an overview of how those function. So network firewall. Customers have lots of different options for how they employ firewall services in their environment. And we have lots of conversations with customers around this. Some customers today have self-managed solutions that they're using to do this with. A big one I talk to customers about is squid proxy solutions that are using as a means of securing what domains they're allowing their workloads to communicate with. Typically, customers are looking to move away from these type of self-managed solutions just because they're hard to manage at scale. And we also talk to customers who are using third-party solutions as well. So this would be, say, like a Palo Alto or Checkpoint or Fortinet VM series firewall. And they're using these to do similar things. What this means underneath the hood is that typically they're going to have to manage those EC2 instances. Sometimes we'll see customers who use gateway load balancer in front of them to provide some extra redundancy. Every now and then we'll talk to a customer that's still routing traffic back to on-prem for inspection, just because they already have firewalls in place there and have policies that they know and trust. And lastly, we have the cloud native, which is where network firewall falls. And more we see customers being driven to this approach, customers looking to essentially standardize across cloud native for all their security services. So what do you want to learn? What do we need to know about AWS Network Firewall? First of all, it's a highly available service. So what that means is underneath the hood, you don't have to manage anything other than where you put your endpoints in the environment and how you are going to route traffic to those endpoints and what policies are going to be on them, which we'll be talking about later. But the service can scale up to 100 gigabits per endpoint. So it's a fully managed service. It also comes along with managed rule sets that cover both threat signatures and domains that you can employ. It also uses underneath the hood a very powerful and flexible rules engine, Suricata, and we'll be talking about that in more detail later. And that flexible rules engine allows us to do deep packet inspection. So what we can do there is look at application verification, protocol verification, looking at some of the particular characteristics of specific protocols to look for both signs of potentially malicious or suspicious behavior and make sure that only the protocols we expect are going to the internet. In terms of top use cases, far and away, the one we see customers employing network firewall for the most is egress filtering. So that's traffic leaving the environment, say going through a NAT gateway on its way to the internet. And by and large, they're looking to do domain-based filtering, usually with some combination of both allow list and deny list. So a deny list being like, we're going to block stuff that we know to be bad or malicious. Again, some of that is supplied by network firewall. And more we're seeing customers who want to specifically limit their communications externally only to domains that they trust. So a lot of customers that we talk to are kind of somewhere in that journey towards trying to move to a more strict allow list. Also employing the AWS managed IPS rules to give them, a sense of what sort of potentially interesting or suspicious things their workloads in the environment might be trying to reach out to. A secondary use case we often see as well is just for east-west use cases in filtering between environments. So a common thing we might see here is where the firewall is attached to a transit gateway in an inspection VPC, and then it's filtering what traffic is allowed between various VPCs in the environment. So between maybe your prod and your dev environment, you do need to allow certain very specific connections, and you can use network firewall to make sure those kind of that window of what's allowed is as narrow as possible. And with that, I'm going to hand off to Jesse, who's going to go through the top 10 best practices.
Thank you, Michael. All right, let's dive right into the top 10 best practices for network firewall. So number one is ensuring that your basic routing is set up when you deploy network firewall. When you deploy network firewall into a VPC, you do need to modify the route tables to ensure that traffic is sent over through network firewall. So network firewall does not support asymmetric routing at all. And this tends to show up in deployments where we see that customers have deployed network firewall in conjunction with the NAT gateway. And the NAT gateway subnet has to know how to return traffic to network firewall. So it's important to make sure that your routing is in place correctly for both the routes defining how traffic leaves the VPC as well as how traffic returns back to the VPC. We also see this pop up with transit gateway deployments. When you're using network firewall and transit gateway together in a centralized deployment, you do want to ensure that you have appliance mode turned on your transit gateway. So let's take a bit of a deeper dive into that first architecture we see with NAT gateway. This is specifically the route table that oftentimes will be overlooked, that has to be there to return traffic back to network firewall's endpoint. So a lot of times the route tables will be modified to send traffic outbound to the network firewall just fine. That looks like it's in place. And then sometimes that return path will be forgotten. So really want to make sure that you get both of these in place when you're deploying network firewall. In terms of the TGW transit gateway centralized deployment with network firewall, it's important to make sure that if you're using network firewall for an east-west use case where you're inspecting traffic between different VPCs, that you use appliance mode. What will happen if you don't use appliance mode is the return path traffic might actually land on an endpoint in a different AZ, and the firewall won't understand the full context of that flow and be able to correctly process it. So it's easy to turn on appliance mode for TGW. It's actually in the console now. This checkbox here allows the TGW to understand how to correctly return traffic through the network firewall endpoints in the appropriate way. Number two best practice is to use strict order and drop established. Within network firewall, there are two main options for how the Suricata engine is going to process the rules. The default option is the Suricata default that doesn't allow a lot of flexibility. It's more geared towards an IDS use case instead of an actual firewall use case. So we do recommend that customers choose the strict option, and this will help the Suricata engine know to process the rules in the order that you have defined the rules. There's some sub options that go along with that. The most important one here is the drop established and the alert established. What this does is it says that network firewall should process the rules in the order that you define and only allow traffic that you are explicitly allowing and deny everything else. So usually customers will start out using the alert established. That will provide their logs with a lot of context for what traffic would be blocked, what traffic is outside of what is being allowed explicitly. And then they can move on to using the drop established option, which gives you that default deny. So just to kind of summarize, it allows for user-defined rule processing, logging of allowed traffic, which we'll talk about more deeply here in a minute. It also supports the managed rule groups and a default deny status for the firewall, as well as the domain rules. Number three, best practice for network firewall. Network firewall has stateless rules, and it also has stateful rules. And in the UI, the stateless rules show up first. But we really see that customers need to move on quickly to the stateful rules. Those are the rules where you're really going to spend most of your time configuring and getting deep packet inspection, IPS capabilities out of the firewall. The stateless rules will override the stateful rules. So it's important to know that anything that you configure in your stateless rules that would prevent the stateful engine from seeing that traffic. There may be some valid use cases for that. If you don't want the traffic to be logged at all, maybe you want to deny it and not throw an alert on it. These can be used in those situations, but for the most part, you're going to want to leverage the stateful rules for your firewall policy. These rules are great because they allow you to automatically allow the return traffic, so I don't have to define rules to account for traffic going out and then back in as a part of that same flow. So they are fully stateful, right? And then they also support deep packet inspection, really diving into the application layer 7 attributes of that traffic, and gives you fine-grained control and visibility over that, which we'll dive deeper into as we look at those Suricata rules. It does support standard firewall logging, which will log all of your 5-tuple firewall flow information. But in addition to that, the protocol analysis that Suricata can bring from the deep packet inspection. It is easier to troubleshoot these rules. And the rules, these stateful custom rules also support rule descriptions. So they give you a lot of flexibility for adding what date did you put the rule in, comments about that rule, what is the use case for the rule. They're very flexible, as we'll see. They also support the reject action, and the capacity calculation for these rules tend to be easier to work with than using the stateless rules. In the UI, the Suricata rules show up under the stateful rules, and over on the bottom right here you see the IPS Suricata compatible rules. Our fourth best practice is to use these custom Suricata rules. A lot of times customers will start to configure things in the other rule options and later realize that they really want to support multiple use cases together, and those are easier to accomplish using the custom Suricata rules. So we recommend customers check those out early as you're starting to work through your firewall deployment. The custom Suricata rules, here's a quick snapshot of what those look like. Michael Leidy is going to do a deep dive into the rule syntax here. But this is a free-form text that you can have full control over. And so it allows you a lot of flexibility for how these are going to be written. It improves your flexibility. It also gives you much more control over what the message alert is going to be, how you want it to show up in your log, what signature ID you want to use. And a big positive side to using the custom rules is because they're free-form text, I can now copy and quickly modify, edit, share, and easily have a backup copy on my laptop. And it's very easy to switch these rules from one rule group to another rule group. Maybe I want to do like some blue-green testing. These rules allow for that type of flexibility. And they also allow for much more specific traffic handling. So if we look at our rule groups, this is just a snapshot. At the top here, I have some managed rules. AWS Network Firewall comes with AWS managed rules that include threat intelligence that we keep up to date on your behalf. Definitely encourage you to take advantage of those. And then down at the bottom here, you'll see that I have a single custom rule group. So our number 5 best practice is to use as few custom rule groups as possible, and we'll go into why that is. But this is a pretty good snapshot into what your overarching rule set might look like. So the custom rule groups, the reason that I want to use as few of those as possible is because each one of those, when I create it, I need to define a capacity. And the capacity, I might want to expand that later on. I might want to have additional flexibility there. So you want to give yourself extra headroom when you create those and use as few of those as possible. What tends to happen is if I use a lot of my own custom rule groups, I have to lock in the capacity. And so it doesn't allow for as much flexibility as I would like later on. And then it also makes it more complex to understand from a high level how traffic is going to be handled. Because now what would happen is I need to go into each of these rule groups, understand how that rule group impacts my traffic, and then look at that for each rule group. And so it's much easier to do that if you're utilizing fewer rule groups and putting most of your rules into those fewer rule groups. Makes it easier to identify situations where you might have rules that overshadow or conflict with other rules. You can see it in one page. Oh, hey, that's not quite what I wanted, and adjust it there instead of having to jump out into different rule groups. Network Firewall does have a hard limit of only supporting 20 rule groups at the moment. So you, depending on the managed rules that you're using, you want to consolidate your rules in a way that gives you headroom and scalability to support your use cases. So be thinking about that sooner rather than later as you're building out your policy. If you do use multiple custom Suricata rule groups, you want to make sure that as you're providing your signature IDs inside of each of those rule groups, that you use unique SIDs, and I mean unique to all of your rule groups. So not just unique to that individual rule group, but unique to all of your rule groups. It'll help you out as you're thinking about looking at your logging and understanding how traffic was really processed by the firewall rule set. And we'll dive deeper into that as we look at the Suricata rules. Number 6 best practice is to ensure that you have correctly defined your HomeNet variable. When you first deploy Network Firewall, it is going to define this variable for you as the CIDR range of the VPC where Network Firewall is deployed. So in this architecture, it would be this inspection VPC CIDR range. Now you'll notice in this architecture, that CIDR range is different from the CIDR ranges of the other VPCs that I might want to actually protect with the firewall. So I want to make sure that this HomeNet lines up with all of my CIDR ranges, not just the single VPC. That HomeNet variable can be set globally now at a policy, at a Network Firewall policy level. I can go ahead and define what I want that to be. That's a great option that customers should consider starting with. You also have the option to define your HomeNet variable per individual rule group. So it does support both, but you just want to make sure that you go ahead and set those correctly. This is what it looks like in the UI to set that policy, that global variable in the firewall policy. Number 7 best practice is to use alert rules before pass rules. This allows for use cases where maybe you have a mandate to log everything. Even if that traffic is denied or allowed, you want to log all of it so that you can do analysis later on. In order to do that with Suricata, today to allow traffic, you use what is called a pass rule. And the pass rules don't log the traffic. They essentially allow the traffic and ignore it. But in order to log that traffic, the way you would do that is just add another rule that alerts on that same traffic before you allow that traffic with a pass rule. And as long as you're using strict ordering and you have the alert rule as a higher priority than the pass rule, then you'll go ahead and get the visibility that you're needing. If we zoom in on this, we just have a quick reminder in the message field. Again, since pass rules don't actually send a message, we're kind of using this message field just to remind us that pass rules don't alert. But if I want to look for the alert for this traffic, I would look at the SID ending in 744. And you'll notice my top rule has a SID ending in 744. You'll also notice that I'm using a longer SID signature ID here, and there's a really good reason for that. By default, there's kind of a tendency to make your first rule SID number 1, your second rule SID number 2. It will support that, you can do that, but when you go to search your logs for the number 1, you're going to get a lot of hits on things, right? That number is going to show up in IP addresses, etc. So it's very valuable to use a longer SID, and then we also see that it's really valuable to make that maybe a date that you put the rule in, or some sort of unique identifier that helps you understand other context related to those rules. All right, number 8 best practice. This is Suricata Keywords that Michael's also going to dive into a bit deeper. But as you're building these custom Suricata rules that we highly encourage you to start working with, you need to be mindful of the way that Suricata handles traffic, and that there are some interesting keywords you want to include in those rules. So this is actually an example of a conflicting rule set. When you first look at the rules, like, okay, I think I understand how the network firewall is going to process that traffic. But if you think about how, you have different layers of the OSI model, you have applications beginning usually with a TCP connection, and then they're working their way up to an application level, in this case TLS. What's going to actually happen in this rule set is if we think about that TLS connection, it's going to start at a lower level in a TCP. So that TCP packet would actually be triggered and blocked by Rule 2 in this situation before Rule 1 has an opportunity to see if it's TLS or not. And so because these are lower, we have a lower level rule later in the rule group, and we have a higher protocol rule first. In order to make these rules operate on the same level playing field, we need to add this flow to server established. We do need to add both of those keywords together. And so what that would look like is the simple flow to server established in this second rule makes these two rules operate at the same level and evaluate the traffic at the same time, so that in this case, the TLS rule can allow the traffic before the rule number 2 blocks the traffic. We're doing a high-level overview of this here today, not trying to boil the ocean, but we're super happy to do follow-up conversations with you. We would love to walk through these things more deeply. So please connect with us offline, and we're happy to dive deeper into these as well. But wanted to make sure this is out in front of you and you know about this early to start getting used to, as you're using those custom Suricata rules, including these very important additional keywords. All right, and then number 9, best practice, is around logging and monitoring and helping you get full visibility and troubleshooting capabilities out of the firewall. Network Firewall has 2 different log types. It supports what we call alert logs, and this is really the information from Suricata, the IPS engine, all of the layer 7 attributes and the protocol detection that the Suricata engine can do. That's going to show up in your alert logs. But Network Firewall also supports flow logs. So flow logs, a lot like VPC flow logs, it's this metadata, this 5-tuple information around the flows and conversations crossing the network firewall. And these are interesting because they include the volume of traffic. So if you're looking for anything around what are the top producers or consumers of data within my environment, you're going to want to look to those flow logs because that's where that information is captured. And if you're wanting to identify what are the interesting application layer attributes, what applications are being used, what domains are being used in my environment, those type of attributes are going to show up in your alert logs. CloudWatch logs is a great destination that we see customers starting out with for Network Firewall. CloudWatch includes a solution called Contributor Insights that is particularly helpful for understanding and building dashboards to help you interpret this log information. What we'll typically set up there is things like top protocols used, top domains blocked, top domains allowed, just getting that top talker information there, top instances being denied, being allowed, top managed rules, blocks, all that basic high-level overview of what's happening in your environment during that time can be really helpful to see on a single dashboard. CloudWatch is great about, I can build these individual contributor dashboards, widgets I believe they're called, but then I can see a timeline. So if I scroll over any part of it, it's going to line it up and I can start to see how these attributes are related to each other. And that can be very helpful for understanding what's happening with traffic in my environment. Again, the flow logs, similarly, I can use Contributor Insights against the flow logs to understand what are the top domains using bandwidth across my network firewall. What are the top source IPs, source instances using bandwidth across the network firewall. And then again, Suricata is really that layer 7 deep packet inspection engine that's producing the alerts into the alert logs that is going to give you, valuable insight into the application traffic. And we can provide examples of those Suricata rules. Leidy will also walk through a lot of those. I think the main point on the Suricata front is a lot of customers aren't really aware of the power and the flexibility that Network Firewall has. And so you want to start looking into those Suricata rules sooner rather than later to get full advantage from them. And then number 10 is about how do we deploy network firewall in a way that's adding value and cost optimizing that. The number one thing we see on this front is, let's say I have an environment with hundreds of VPCs maybe, and I decide I want to protect all of my VPCs with network firewall. There can be an initial idea and kind of temptation to deploy network firewall into each of those hundreds of VPCs. Well, for each endpoint that you deploy, you are going to incur hourly charges for the network firewall endpoint, even if there's no traffic crossing it yet. And so you want to be mindful of that. And we see that for medium-sized customers to large customers, they really want to deploy network firewall in a centralized architecture with transit gateway to help with this. What this means is I can have 3 or 4 network firewall endpoints that are servicing traffic for hundreds of VPCs. And that helps reduce my cost on the network firewall standpoint. And it also helps make sure that as I'm deploying and using network firewall, the value that I'm getting out of it for the traffic that's crossing it is what I'm really being charged for mostly, and not just having that endpoint sitting there idle, accruing hourly charges. The next one here is you can actually segment traffic using transit gateways route tables. So if you want and you have environments that don't need to talk to each other at all, we first might think, well, send it to a firewall, and then have that firewall block VPC prod from accessing VPC dev, that sort of scenario. That's valid. You can do that with network firewall, but you can also do that kind of large, wide segmentation from using just the route tables on transit gateway. So rather than sending that traffic over to network firewall and incurring the network firewall network processing charges for that traffic, you could just segment that traffic and black hole it at TGW if you have that type of segmentation needs. So that's a great option to help reduce your network firewall costs. Number 3 here is around Amazon S3 and DynamoDB. Both have gateway endpoints VPC endpoints that you can leverage so that your workloads have direct access to those services without having to transmit that data over network firewall. So network firewall's costing is around endpoint hours as well as data processed. And you can imagine some environments have a lot of S3 data that would be processed that you may not actually need network firewall inspection for. So what you can do there and what you can do with any AWS service that supports endpoints is just make sure you have those endpoints in place to reduce the network processing charges on network firewall. This also is really helpful because some of those endpoints, you might have VPC endpoint policies to help secure and provide data perimeter protections at that layer. And so network firewall will see where you might have VPCs that haven't yet been configured with those endpoints and that you might want to follow up on. You can also use network firewall to just block that traffic outright to kind of force compliance that you're using those VPC endpoints and those VPC endpoint policies. Ensuring that your route tables send traffic to a local network firewall is important. You can configure your route tables in one AZ to send traffic to a network firewall that actually exists in a different AZ. You're able to configure that, but if you do, you will incur cross-AZ networking charges. So typically you want to have the network firewall in the AZ where your workloads are configured in your route tables to process that traffic. And then the last one here is you can use DNS firewall to filter out traffic that maybe you don't even need network firewall to process at all. So you could have some basic blocks at the DNS layer, and those will be blocked and keep that traffic off of network firewall. Not going to read every one of these, but this is a great slide here to just take a picture of as you're thinking about your network firewall deployment. These hopefully will be very helpful for you and make the process a bit more streamlined. And now I'll pass it off to Michael Leidy to work through the custom Suricata rules.
Thanks, Jesse. All right. So as Jesse mentioned, we'd love to talk to you about this afterwards. What I'm going to be going through here is pretty much kind of skimming the surface of what you can do with the Suricata rules, and it's not exhaustive in any nature or scope. Also, I have a workshop that if you're interested, you can go through in terms of like having an environment to go around and play around with crafting these rules. That could be helpful rather than doing it in your own environment. So Suricata rule syntax, it's composed of these 3 different areas, which we'll go through in more detail. But first is the action that's going to determine what actually happens when a particular rule matches. We have the header that deals with basically the protocol, IP address, and the ports and the direction of that rule. And then we have rule options, and this is where it gets really meaty. Suricata has very exhaustive and long list of rule options that can get pretty complex. Again, we're going to just skim the surface of that today, but if there's pretty extensive online documentation for Suricata that you can go into and explore. Most of those options are supported by Network Firewall. There's a few exceptions to that, and I would point you to the Network Firewall documentation where it talks about some of those exceptions. So first of all, we're going to look at that alert. So it deals with the action, and then we have next the header portion, and then finally we have the rule options. And you can see that rule options portion is much longer, a little bit more involved. So starting with the action, we have these 4 different options that you can select for the action. The first one is to pass traffic. And as Jesse noted earlier, passing traffic immediately passes it through the firewall. It doesn't make a log entry. No other actions are taken against it. So be aware of that when you use pass rules, that traffic is not logged. Alert rules you would want to have before pass actions if you wanted to log them. An alert rule is not a terminating action either. So an alert rule taking an action will log a message related to that traffic, but that packet or traffic could still be matched against other rules in your policy. Also, we have a drop option. This is the default option for most of the block stuff within Network Firewall. What it does is it just silently drops the packet, and there is no response sent back to the client. Reject, on the other hand, will send a TCP reset back to the client and effectively letting them know that traffic's been blocked. So next we're going to talk about the header portion, and we'll start off talking about protocol options that Suricata has available with that little blinking TLS. So under protocol options, we have the standard kind of high-level protocols that we can select between. We have TCP, UDP, ICMP, and then IP will match all those above. So I can narrow the scope of what I want to match against to one of these, or I can be very inclusive by using IP. We also have layer 7 protocols that we can match. Again, this is a pretty long list that Suricata supports, but these are some of the top ones we see customers using. HTTP for matching HTTP traffic, TLS, which matches TLS over HTTP, DNS, SSH, and NTP are other common ones we see used. Next, we're going to look at the source and destination portions of the header. So we already talked about this in a little bit of detail, but the HomeNet variable is typically what you'll see used to match traffic coming from your network. And by default, Network Firewall is set to be this value to be the VPC CIDR range. So in cases where you're doing some sort of centralized inspection with Transit Gateway and have many different VPCs involved, you definitely want to override this value. We also will often see a negation of HomeNet, otherwise known as external net. And so what this matches is essentially the opposite of HomeNet. So anything that's not in HomeNet will be matched by that with these 2 variables. Another example of doing negation with just a single IP address, just for an example. So this particular designation here will match anything that's not in that list. In this case, it's just one IP address. So any IP address that doesn't match 1111 will be matched by that value. You can also do this with groups of IPs. So I could put these into a group separated by commas and then put the negation in front. What that's going to match is any IP address not 1111 or 1112. And I can also do this with blocks of IPs. So in this case, we have a whole /24 in a 10 network that's being matched. And along with that, we're adding an exception. So we're putting a negation to a single IP address within that range, so it'll match all of that range except the one IP address that we're not allowing. Similarly, we match on ports as well. It's very common in the case that we'll use any for some of those higher layer protocols that we want to match against, but we can also drill down and be very specific with these as well. So any obviously will match against any port. I can also explicitly list numbers of ports, comma separated. I can do ranges by separating them with the colon here. I can also match all the way up to the highest port. So if you're talking about doing source port validation, which is using very high ports, it may be useful to use some of these higher ranges. So here, this designation here is going to match from 1024 all the way up to the highest port allowed. I can also do negations with ports. This is something we'll see a lot of as well. So everything, the bang in front of the port 80 is going to match everything but port 80 here. And then similar to how we could do with the source and destination for IP addresses, you can do the same thing with ports. So I can designate a range and say just this one particular port within that range I want to accept from the range. Another thing we need to understand with Suricata rule syntax is the source and destination have this little arrow in between them that designates which way the traffic's flowing. Suricata supports two different options. Most of the time you'll use this first designation here where it's going from source to destination. You can also match traffic flowing in both ways. Recommendation is that you don't use this except, maybe you have some instance where you have a specific need for it, but most of the time it's best because the Suricata rules are stateful to match in one direction and knowing that the stateful rules engine is going to allow the traffic for that entire flow. Suricata does not support going in the opposite direction, so if you try to do that, you'll get an error back. Okay, so now we're going to look at the rule option portion. Again, just really skimming the surface of this because there's many different keywords that can be applied here, but we'll go through some of the more common ones that we see customers using in their custom Suricata rules. So a big one that we see, Jesse mentioned this here, and we recommend using it, is the flow keyword. And it's going to give me control over specifically what packets in a particular flow I'm going to match against. And so I can match flows only, packets only in established connections. And so I would use that established keyword to do that. You can also do not _established to do the exact opposite of this, match packets that are outside of an established connection. You can also use the stateless keyword, which will match both in and out of established connections. Jesse also talked about the to-server. This just makes it very clear which direction the traffic is flowing and adds some predictability to the rules. We can also put in a message field within it. And the recommendation here is that you put in something that's informative. We do see some customers, they'll actually put say a ticket number associated with the, a rule being approved or something like that as a way of tracking it. But anything you put in here is going to be part of your logs, so it makes it easier to find and figure out what was going on if you have something informative here. And last we have the SID. Within Network Firewall, it's going to enforce SID to be unique, but it only does that within a single rule group. Recommendation here would be to have a globally unique SID. Something that I like to use is just use the year, month, day, and then have a unique number after that for the rule. And this makes it very easy to go back and track a specific instance of a rule as you go through different variations of it as well. So now that we've been through this, I'm just going to walk through some rules, and what I'm going to do is just put it on the screen and give you all a moment just to look at it and see if you can figure out what it does. Some of these should be obvious if you worked with Network Firewall for a while, but hopefully we'll all learn something in the process here. I've taken out the message field, which again would be recommended, but just so that you don't have anything that's giving away what it's doing, you can just look at a more simplified version of the rule and figure out what it's doing. So this is an alert rule. It's the only thing it's going to do is put a message into the logs. It's not going to take any other action, and it's matching specifically TLS traffic. You'll notice that it's specifically looking at traffic coming from my home network and it's leaving my home network, so that would be going typically to the internet, and we're matching that on any port. So whether it's going on the traditional 443 or it's going on some other port using TLS, maybe it's using start TLS for SMTP traffic, this will be matched as well. And you can see we're using the flow to server established. And so what this is going to do is make sure that it's looking only and matching packets are in an established flow. So ultimately what this is going to do, any kind of TLS communication going to the internet, we're going to have an alert against it. And typically we'll see customers will use this rule just like this when they're starting out with Network Firewall. A lot of customers are looking to build allow list rules around specifically web communications going to the internet. Oftentimes they're replacing, say, a squid proxy that's doing that validation today. And so when they move over to Network Firewall within their cloud environment, they want to say, figure out what are these workloads communicating with today. A workload like this can help with that. All right, so this one changed very slightly from the last one, and it's doing something very similar. And it's the only difference really here that's changed is that we changed TLS to HTTP. And again, reason why customers would put a rule like this in place is they're looking to just identify what web communications are going out of the environment. It's looking over any port. So a lot of customers that put this into place in their environment will find all kinds of little weird idiosyncrasies of like how communication is flowing in their environment. Hopefully, you don't have a ton of HTTP traffic going to the internet, since that's obviously in the clear traffic. But this is a great way of getting your arms around what you're going to need to build your allow list rules for when you're starting off with Network Firewall. So I'll give you just a moment to look at this and try and figure out what it does. Hopefully, after all our education here, you can figure out what this rule is doing. So we have our first drop rule, and it's specifically matching against HTTP traffic. And again, it's going to match that from any source port. But if we look at the destination port, it's only matching on anything that's not on port 80. So effectively, what is this rule doing? It's looking for any sort of weird usage of HTTP, right? So it's saying, if you're not using the standard port 80 for HTTP, you're not allowed. We're going to drop that traffic. And it is very common that we do see kind of IOCs related to malware and rootkit downloads where they're using HTTP on a weird port. And again, you probably want very little HTTP leaving your environment in the clear. So typically rules like this can be useful to help control what traffic is leaving your environment. This next rule here is doing something similar, except we're limiting our inspection to just UDP traffic. So I'll give you guys a moment just to look at that and see if you can figure out what's going on. This rule is a little bit different than the other rules we've looked at because it is using an app layer protocol to do the validation, but it's using it within the keyword. So before we had all those app layer protocols fronted at the beginning, here it's part of that, the rule options there at the end, so you can see where it says app layer protocol. We're looking for and matching against anything that's not NTP. So effectively what this rule is doing is it's validating whether we have NTP traffic going to port 123 over UDP. So this is often the case that customers need to allow, they do some sort of time synchronization for their workloads, and oftentimes those time servers that they're syncing with are out on the internet and they want to allow that traffic outbound. But we don't want to allow an easy door out for other protocols as well. So often we know attackers know there's a whole certain range of protocols that might be open, and this is one of them. So effectively what we're doing here is just validating what that protocol is before we allow it out the door. Next, we have another drop rule doing something very similar. It's looking to validate, and again, it's using that app layer protocol, and we're doing a negation of TLS to say anything not TLS going to port 443, we're going to drop. Again, why would we want to do this? What we're effectively saying is we're reserving this port for TLS traffic. We want to make sure there isn't anything else that is squeaking out the door because it happens to know that we need to allow this kind of traffic out, and it's trying to use and disguise itself as the same traffic by using that port number. All right, this one's a little bit longer in terms of the rules options, so I'll just leave it on the screen just a little bit longer, see if you guys can figure out what exactly it's doing here. So what we're looking at here, again, it's a matching, it's a drop rule, and it's matching against HTTP that's leaving my environment. We have a new keyword that we haven't used previously, looking at the HTTP host field. So the HTTP host header is a field that indicates to the web server being communicated with what specific domain name is being requested. Usually this should have some sort of FQDN in it. And what we're doing here with this rule is we're looking for just an IP address in there instead of the normal host header. And so the way we're doing that is we're using the content keyword. Content allows me to do very simple matching. You can see within that content field, there's just a period. So we're matching any content within the HTTP host header that has a period. And then furthermore, we're doing a Perl regular expression after that. And the regex is just simply looking for signs of a full-on IP address in that space where we would expect there to be a fully qualified domain name. So why would we want to do this? Oftentimes we will see that malware going to the internet will go direct to IP. It won't do a DNS lookup. And so this is just an easy way of taking traffic that we know probably could be malicious off the table. Anything legitimate should be communicating with a domain name over the longer term. So it's just an easy way to take some risk off the table. All right, and now we're kind of moving into some of the rules that you would use to build your allow list with. So we looked at earlier at the beginning some alert rules to kind of gather the data that we'd want to use for validating domain names being communicated with externally. Now, if we wanted to build out that allow list, we would start using rules that look similar to this. So we have another new keyword here. We're using the TLS.SNI as a means to do that. We have the dot prefix keyword. That's another new one. Effectively, what that does is it prefixes a dot to the beginning of domain names, and what that does is allow us just to match subdomains as well. So for the content here that's matched, period, AmazonAWS.com, there's a prefix that's being added so that it'll match not only the root domain, AmazonAWS.com, but any of the subdomains with it as well. You can see we also have a keyword for no case, so basically saying we don't care about case here. If there's anything capitalized, whatever, it doesn't matter. And we're also saying ends with to make sure we match the end of the TLS SNI. So effectively what this is going to allow us to do is communicate with any of the web services that are underneath that AmazonAWS.com logo, and or domain rather. And this is kind of the sort of broad-based allow listing at a kind of second domain layer level that we see customers using. They'll get SNIs that are longer than that and figure out what are the commonalities to say here's the domains that we are going to communicate with and trust. And then last, we have a similar pass rule that you might want to have in your allow list. And here we're using HTTP. So it's, again, probably don't want to allow a lot of this, but it may be the case that you have certain internal requirements where applications are still communicating over HTTP, and so you're going to limit those specifically. Again, we're using that HTTP host header field. We're using the dot prefix, and here we have the content of a match to .yourdomain.com. So this could be fill in the blank for your company, any of those subdomains that are underneath your corporate domain could be easily matched here. And again, it has that no case, so it'll match any case variations and an ends with. And so what this these last two rules would be kind of the building blocks for building out a rule that allows just specifically the domains you want to communicate with. And then kind of typically what customers will do in the end is they'll terminate that action with a drop established. So anything not on that allow list will be effectively dropped. So that's it for the presentation. Thank you all so much for coming. If this was at all helpful, if you learned anything, please give us feedback. We'd love to hear it. Also, Jesse and myself are going to be around waiting, so if you guys want to have a conversation, want to go grab a coffee or something like that and talk about your particular use case, happy to do that. Also, connect with us on LinkedIn, send us an email. We love to have conversations with customers about either how you're using Network Firewall today or things that you would like to see in the coming in the features for the service. So thanks again for attending, and look forward to talking to you all.